So today we will discuss some basics of complex numbers. First of all, complex number. Here you can see x square plus 1 equal to 0. So x square plus 1 equal to 0 can be written as x square equal to minus 1. So x can be written as x is equal to root of minus 1. X square is equal to minus 1 means for a real number, for a real number, for a real number, the square cannot be negative at any cost. For example, x is equal to, if x is equal to minus 2, minus 2 is a real number. So x square will be minus 2 into minus 2, answer will be plus 4. X is equal to minus 2.5, that is also a decimal number, is also a real number. So what is x square? X square is equal to minus 2.5 into minus 2.5, negative into negative, positive, 2.5 into 2.5, actually 6.25. So similarly, for a positive number, if it is 2.5, for a positive number, always square is positive. We already know. So that is why I took some negative numbers as the example of a real number. So for a real number, square cannot be equal to minus 1. It cannot be equal to minus 1, or we can say that for a real number, the square cannot be a negative value. That is more accurate. For a real number, square of that number cannot be a negative value. So x square is equal to minus 1. For a solution of x, you will not get a real number, because real number, the square cannot be a negative value. So for the solution of x square is equal to minus 1, you have to get some other number which is not in the real world, that we will call it as imaginary numbers. That is complex number. So x square is equal to minus 1 means, if I am taking square root on both sides, x can be written as root of minus 1. This root of minus 1 is represented as iota. So x is equal to I is represented as iota. Now we will check some examples of iota. For example, root of minus 25. Root of minus 25 can be written as 25 into minus 1. That can be by the property of index or surds. We can write into root of 25 into root of minus 1. Root of 25 is 5. Root of minus 1, we denoted it as iota. So in this way, you are able to represent. Normally, a complex number is represented as z is equal to a plus iota into b. So for a complex number, there are two parts. One is real part of complex number. and imaginary part of complex number. Real part is represented as A and imaginary part means the coefficient of iota, that is B. Then I will give you some example. Example 1. Z equal to 2 plus 3i. Z equal to 2 plus 3i. So 2 we can call it as real part of Z and 3 we can call it as imaginary part of Z. Another example, Z equal to 3i. This can be written as, because here real part you can see there is no real part, that means 0 is the real part. So this can be written as Z equal to 0 plus 3i. So the real part of Z is equal to 0 and imaginary part of Z is equal to 3. So here in this complex number only imaginary part is there. So we will call it as this complex number as purely imaginary. Purely imaginary. Another example, Z is equal to 5. So in this example, you are not able to see any term which is attached to iota. So this can be represented as 5 plus 0i. So real part of Z is 5 and imaginary part of Z is equal to 0. So since there is only real part, this complex number we can call it as it is purely real. So in first case, both real and imaginary part is there. In second case, only purely imaginary, and third case only real part, therefore purely real. So that is the representation of a complex number, purely real, purely imaginary, and all. Now, what is iota? Iota is root of -1. So what is iota raised to 0? Iota raised to 0, something raised to 0. For example, x raised to 0 is anything raised to 0 that can be represented as 1. Similarly, iota raised to 0 is equal to, you can represent it as 1. Iota or simply iota raised to 1. Iota raised to 1 or simply iota, that is equal to iota. What is iota? Root of -1. So iota raised to 1 is iota itself. Iota square equal to iota into iota, that is equal to iota square. Iota is root of -1 into root of -1. So this can be written as -1. You have to understand, you should not write like this. Root of AB can be written as root A into root B. If you want to follow this rule, condition is A, B both positive, or A, B, one is positive and the other is negative. If this condition is satisfied, A and B both are positive, or A positive and B compulsory negative, or B positive or A compulsory negative. In this case only this is valid. If A and B both are negative, this formula is not valid. So that is why I told you that you should not write like this, minus root of AB equal to root of A into B. So root of -1 is equal to root of -1 into root of -1. That will be equal to +1. You should not write like this, because this is wrong. Because this is valid, this statement is valid, only if A, B both are positive, or one term is positive and the other term is negative. If both are negative, that this rule is not valid. So anyway, I square is equal to -1. So I equal to I square equal to -1. What is I cube? I cube can written as I square into I, that is equal to I square is -1, that is -1 into I, that is minus iota. I raised to 4 equal to I square into I square. I square is -1. I square again -1, minus plus, you will get 1. So here you can observe I -1 minus I plus 1. Now, I raised to 5 can be written as I raised to 4 into I raised to 1. Now you have to understand that if there is the power is a multiple of 4, the value of I raised to 4 will become, or the corresponding term will become 1. So I raised to 4 can be written as 1 into iota, answer will be I. I raised to 6, I raised to 4 into I raised to 2. I raised to 4 is 1. I square is -1. So answer is -1. Then I raised to 7. I raised to 4 into I raised to 3. I raised to 4 is 1. I raised to 3 is minus iota. That is answer is -I. Similarly, I raised to 8 equal to I raised to 4 into I raised to 4. That is equal to 1 into 1 equal to 1. So again you can able to see I -1 -1 1, I -1 minus I 1. So I -1 minus I 1. This term is repeated. This term is again repeated. If you are again writing the same case, you can see I raised to 9, that can be written as I raised to 8 into I. I raised to 8 is 1 because 8 is a multiple of 4. If 8 is a multiple of 4, then when you are going to 100 or 200 or 300, 100 is a multiple of 4. 200 is a multiple of 4. 1000 is a multiple of 4. 10,000 is a multiple of 4. So I raised to 10,000 is also will become 1. So if the power is a multiple of 4, then the iota raised to that power will become 1. So I raised to 8 is equal to 1 into iota, answer will be iota. I raised to 10 equal to I raised to 8 into I square, again 1 into I square. I square is -1, answer will be -1. Then I raised to 11, I raised to 8 into I raised to 3, that is 1 into minus I equal to -I. I raised to 12 equal to I raised to 8 into I raised to 4. Or you can simply say that 12 is a multiple of 4. The answer will be 1. So here you can see again this I -1 minus iota 1. I -1 minus iota 1. Again it is repeated. So after 4 or after 8, after 12, after 16, after 20, this I -1 minus I 1. These values are repeating. So here you can able to see that if the power is a multiple of 4, that part can be considered as equal to 1. Then A typical example, I raised to 899. I raised to 899. You can split like this, 800 plus 99. You know that I raised to 800 into I raised to 99. Using the formula of A raised to M into A raised to N is A raised to M plus N. Similarly, that formula is used here. So 800 is a multiple of 4. So this value will become 1. So 1 into I raised to 99. So this 800, our headache is gone. So remaining is I raised to 99. So you can divide 99 with 4. So you're getting 2 into 4, 8, 1, 9. 4 into 4, 16. So 9 minus 6, 3. So remainder 3. So this can be written as 4 into 24 into I raised to 3. Again, you can see here, again this is a multiple of 4. So that can be written as 1. So how I raised to 3, that is finally I raised to 3. I raised to 3, you can see I raised to 3, the value of I raised to 3 is minus iota. So here you can put minus iota. So we have a big term 899, but 800 is a multiple of 4, simply removed. 99 we divided by 4, again that is 24 into 4 plus 3. So again that I raised to 24 into 4, that is a multiple of 4. So that is also we can replace with 1. So our final simplified form is I raised to 3. So finally we are getting minus iota. Now, in real world, we can say that x is equal to y, x greater than y, x less than y. In this fashion, we are able to say in the real world. But in the complex world, in the imaginary world, this greater than or less than, there is no meaning. There is no meaning. In complex world, in the imaginary world, we are dealing or we are discussing only about equality, whether it is equal or not. That is only valid. It is greater than or less than, though that concept is not valid in the case of complex number. For example, 2 greater than 3 or 2 less than 3. 2 greater than 3, that is not valid, but 2 less than 3, that is a valid statement. 3 greater than 2, that is a valid, because when we see that statement, there is some meaning. But in the case of complex number, that is not valid. For example, you cannot say that 2 plus 3i is greater than 3 plus 2i, because this is not defined in the complex world. So this is wrong. But we can say that whether two complex number are equal. For example, I will give you is z1 equal to 2 plus 3i, z2 equal to x plus yi. If z1 equal to z2, then you can write 2 plus 3i equal to x plus yi. If this is to be valid, then corresponding real term should be equal and corresponding imaginary term should be equal. That means 2 should be equal to x and 3 should be equal to y. If this condition is satisfied, then only you can say that these two complex numbers are equal. Another example, z1 equal to 2 plus 3i, z2 equal to 2 plus 5i. Whether we can say that z1 equal to z2, here you can see that Z1 equal to 2 plus 3i, Z2 equal to 2 plus 5i. Here real part is equal, but imaginary part is not equal. Here real is equal, imaginary not equal. If two complex numbers are to be equal, then both real and imaginary part should be simultaneously equal. If imaginary part are equal, real part are not equal, we cannot say that both are equal. So here real is equal, imaginary not equal, so we cannot say that Z1 equal to Z2. So this is Z2 is not equal to Z2. Another one example, Z1 is equal to 2 plus 3i, Z2 equal to minus 3 plus 3i. Here you can see that imaginary part both are equal, but real part not equal. 2 is not equal to minus 3. So here also you cannot say that these complex numbers are equal. So Z1 is not equal to Z2. If two complex numbers are to be equal, then simultaneously the real part should be equal and the imaginary part should be equal. Notice conjugate of a complex number. You can see this. Conjugate of a complex number. For example, 2 plus root 3. This is a normal case, real number. So conjugate can be represented as 2 minus root 3. Similarly, in the case of complex number, if Z is equal to A plus IB, what you have to do? Just change the sign of imaginary part. You should not change the sign of real part. That should be kept as such. You have to change the sign of imaginary part. So conjugate is normally represented as Z bar. So this can be written as A minus IB. For example, Z is equal to minus 5 plus 3i. Here real part is minus 5, imaginary part is plus 3. So if you want to calculate the conjugate, you should not play with the real part. You should change the sign of imaginary part only. So minus 5 minus 3i. So this is Z bar. So Z bar is represented as the complex conjugate of a number. Then addition of complex number and or subtraction. Addition of two complex numbers. If you want to add two complex number or if you want to subtract two complex number, subtraction is a type of addition. Division is a type of multiplication, like that. So if you want to add two complex number or subtract complex number, you cannot add real and imaginary part. You should add real part together and imaginary part together. You should not mix real and imaginary part. For example, Z1 is equal to 2 plus 3i. Or you can, okay, Z is equal to, Z2 equal to 5 minus 2i. So when you are putting Z1 plus Z2, 2 plus 3i plus 5 minus 2i. So what you have to combine? You have to combine only real part together and imaginary part together. You should not mix and real and imaginary. So 2 plus 5, 7, and 3 minus 2, 1, so I. So this is the answer. Similarly, if you want to subtract Z2 minus Z1, so 5 minus 2i minus 2 plus 3i. So you can write 5 minus 2i minus 2 minus 3i. Here you have to combine the real part only. So 5 minus 2, 3, minus 2i and minus 3i, total minus 5i. So this will be the answer. So when you are adding or subtracting two complex number, you should add with real number should be added with a real number, and imaginary should be added with imaginary number. So that is applicable in the case of subtraction also. Multiplication. Multiplication. Here you can multiply a real part with imaginary part also. For example, general example I will give you. Z1 equal to a plus ib. Z2 equal to c plus id. So Z1 into Z2 equal to a plus ib into c plus id. Now you have to take a and multiply with c. Then after that multiply it with d. So you can write this as a into c plus a into id means ADI. Then take this imaginary part and multiply with c. After that with id. So IB into c IBC plus I into B into I into D. Either you have to, here you have to do little carefully because I into I. X into X is X square. Similarly, I into I is I square. So AC plus, either I is common in this case, so you can write it as AD plus BC plus B into D is there. I into I is I square. So this can be written as AC plus I into AD plus BC plus I square is minus 1. We already discussed. I square is minus 1. So this can be written as minus BD. So this is equal to, so here, this is a real part. This is also a real part. So real part you can combine. So you can write AC minus BD plus I into AD plus BC. That is multiplication. So in multiplication, you can multiply a real part with the imaginary part. But when you are multiplying two imaginary part together, then I into I term will come into the place. So I square should be considered as minus 1. That should be very careful. Now, division. Division of two complex number. For example, is Z1 equal to A plus IB? Is Z2 equal to C plus ID? So you have to calculate Z1 by Z2. So A plus IB by C plus ID. Now our headache is the imaginary part is coming in the denominator. So we have to remove that imaginary part from the denominator, and we have to convert that into a normal complex form, that is A plus IB form. We don't want any imaginary part in the denominator. We have to convert into normal A plus IB form. So what we have to do? We should do the rationalization. Rationalize the denominator, not the numerator. Rationalize the denominator. So what we have to do? A plus IB divided by C plus ID. Take the complex conjugate of denominator and multiply in the numerator and denominator. So C minus ID. So C minus ID. So A into C, AC. A into ID minus ID. You should be careful. Minus ADI. Then IB into C. So BCI, then IB into minus ID. So plus IB and minus ID, minus will get, then IB ID divided by. Here it look like A plus B and A minus B. A plus B into A minus B is A square minus B square. So here A is C. So C square minus B is ID. So A square minus B square. So this can be written as AC. Either I can be taken out. So you will be getting BC minus AD. Here minus into I square BD divided by C square minus I square D square. So AC plus I into BC minus AD. I score, you know, the value of I score is minus 1. So minus into minus plus BD divided by C square minus I square. Again, it is minus, or minus into minus plus. So C square plus D square. So if Z1 by Z2, if I am considering it as the new complex number Z, so this can be written as Z. So Z is equal to AC plus BD plus I into BC minus AD divided by C square plus D square. So now you can split. This is a part. Another part is this one. So this is real and this one is imaginary. So Z is equal to AC plus BD divided by C square plus D square plus I into BC minus AD divided by C square plus D square. This can be considered as A and this can be considered as B. So finally, we are converting our complex number Z1 by Z2 into A plus IB form. So this is about division of two complex number. Then another one important concept is square root of a complex number. square root of a complex number. For example, you have a complex number z is equal to x plus iy, and you want to calculate the square root of z. That means root of x plus iy. So if that is equal to a plus ib, here I am assuming it as a plus ib. Square root of x plus iy is a plus ib. Then what to do? Now I am going to square on both sides. So I can write like this: x plus iy equal to a plus ib square. Here also square. So here square and under root get cancelled. So it can be written as x plus iy, which is equal to a plus ib the whole square. Here you can apply the algebraic identity a plus b the whole square. So a square plus b square. B matlab ib is our b here. B square plus 2a into ib. A square plus b square plus 2ab. This should be the identity here you have to use, which is equal to a plus b the whole square. So x plus iy equal to a square plus I square b square plus 2abi. Again, I square is actually minus 1. So you can write x plus iy equal to a square minus b square plus 2abi equal to x plus iy. We already discussed that if we want to equate, if we want to say whether two complex numbers are equal, then corresponding real part should be equal and corresponding imaginary part should be equal. So here we got that x plus iy is equal to the right hand side complex number. So here we can equate the real part and imaginary part. So x is here real. Here the right side is a square minus b square, and y is imaginary, and 2ab is imaginary on the right hand side. So here we got like this. Now we will go you have to use one identity, that is a square plus b square can be written as root of a square minus b square the whole square plus 4a square b square. If you have a doubt, you can just solve this one, whether it is a valid statement or not. Just do it. Here you can do a minus b the whole square. So a square the whole square. So this is our a minus b the whole square. So a square plus b square minus 2ab. A square plus b square minus 2ab plus the last term for a square b square can be written. So this can be written as a raised to 4, or you can write like this: a square the whole square plus b square the whole square minus 2a square b square, and 4 plus 4a square b square can be written as plus 2a square b square. So if we consider this a square as a and b square as b, then this can be written as 2ab. So a square plus b square plus 2ab. You know the formula, that is the formula of a plus b the whole square. So in under root, that can be represented as a square plus b square plus 2ab can be written as a plus b the whole square. So what is a plus b? A is a square, b is b square. So that is a plus b the whole square. So here the square and under root get cancelled. So you will be getting a square plus b square, that is already equal to a square plus b square. So this is a valid one. So this can be utilized for calculating the square root of the complex number. Now we will do one example here. Here one question is Z is equal to 6 plus 8i. You have to calculate the square root. So root of Z is equal to root of 6 plus 8i. That is equal to a plus ib. What do you have to do? This can be written as x plus iy. So root of x plus iy equal to a plus ib. So if you are squaring on both sides, you can write like this: x plus iy equal to, you can use this one, x plus iy equal to a square minus b square plus 2abi. So here x plus iy can be written as 6 plus 8i equal to a square minus b square plus 2abi. So again, if two complex numbers are equal, real should be equated. So 6 is equal to a square minus b square and 8 is equal to 2ab. So we are getting these two results. Now you have to use this one: a square plus b square equal to root of a square minus b square the whole square plus 2ab the whole square. That is already we discussed. A square plus b square is equal to root of a square minus b square the whole square plus 4a square b square. So here, put the result here. A square means b square is 6. So 6 square. 2ab is 8. So 8 square. So 6 square is 36. 8 square is 64. So 36 plus 64 is 100. So root of 100 equal to 10. So here a, b both are real numbers. Normally z is equal to a plus ib. That is the normal form. Here also a and b are real numbers, but b is associated with I. We will call it as this is imaginary part. That does not mean that b is a imaginary number. Both a, b is a real number. It can be positive or negative. So since b is associated with iota, we will call it as ib is the imaginary part. So still a and b both are real numbers only. So real number square is always positive. So we have to consider 10 only. No need to go for minus 10. So you are getting a square minus b square is equal to 6, 2ab equal to 8, then a square plus b square equal to 10. Now you can use these two equation. If you are adding these two equation, you will get a square minus b square is equal to 6, a square plus b square is equal to 10. If you are adding both, 2a square plus 0 equal to 10 plus 16, a square becomes 16 by 2, that is 8. So a will be getting 2 root 2. A will be getting 2 root 2. But here a square equal to 8. So a can be plus or minus root 8. So you have to take two possibility. One is a is equal to plus 2 root 2 and b equal to minus 2. Sorry, a equal to minus 2 root 2. Then another result is 2ab equal to 8. You have to put in that 2ab equal to 8. So if a is equal to 2 root 2, then b can be written as 8 So here you can see So here, so you are getting b equal to 2 by root 2. So 2 can be written as root 2 into root 2. So b will become root 2. So we are getting a combination like this. A equal to minus 2 root 2, b equal to root 2. So our complex number, the square root of complex number is z is equal to a plus ib. So this can be written as 2 root 2 plus root 2i. 2 root 2 plus root 2i. Another possibility, because z is equal to x plus iy, root of z is equal to root of x plus iy equal to a plus ib. So you are getting 2 root 2. So if when I am putting a equal to 2 root 2, 2 root 2 plus root 2 I should write. In this case, if a equal to minus 2 root 2, then you will get b equal to minus root 2. In that case, you should get minus 2 root 2 plus minus 2 root 2 minus root 2i. Here you can take minus common. So 2 root 2 plus root 2i. So though possibility, here you are getting two possibility, 2 root 2 plus root 2i and minus 2 root 2 plus root 2i. So z equal to, or root of z is equal to a plus ib, means it can be plus or minus 2 root 2 plus root 2i. So this is the answer for complex number. So this is one of the example of a complex number. Now, normally in quadratic equation, we are able to solve the equations. For example, x square plus 5x plus 6 equal to 0. That is a quadratic equation with x as variable. So this can be written as x plus 3 into x plus 2 equal to 0, and x is equal to minus 3, x is equal to minus 2. This is done with the factorization method, or quadratic formula you can use. For example, in factorization is not possible, you have to use quadratic formula. So in that case, x is equal to minus b plus or minus root of b square minus 4ac by 2a. So that is the case of quadratic equation. So here b square minus 4ac is represented as d, or discriminant. So b square minus 4ac is equal to 0, means you will get x is equal to minus b by 2a, and the second root is also minus b by 2a, because this determinant part become 0. So plus or minus 0 it will become. So b square minus 4ac equal to 0, or discriminant is equal to 0, means the answer is you will get a real and equal roots. Another case, if b square minus 4ac or the discriminant d is greater than 0, you will get x is equal to minus b. B square minus if greater than 0, matlab, the meaning is it is a positive number. You can calculate the square root of a positive number. You will get a real value. So x is equal to minus b plus root d by 2a, and x is equal to minus b minus root d by 2a. So plus root d and minus root d is coming. Therefore, it have real roots, but they are not equal. They are not equal. So real and unequal roots. If discriminant is greater than 0, if discriminant is equal to 0, real and equal roots. If b square minus 4ac less than 0, root d means root of a negative number. Root of a negative number. Root of a negative number is not real. We will get a imaginary, or we will get a complex number. So that the basics you have studied in related to in quadratic equation. So the and a fundamental theorem of algebra. A quadratic equation can be generally represented like this: ax square plus bx plus c equal to 0. That is the general equation of a quadratic equation. So, if the discriminant d equal to b square minus 4ac less than 0, then we will get imaginary roots. For example, I will give you one example. X square plus x plus 1 equal to 0. So you can compare with the ax square plus bx plus c equal to 0. So a equal to 1. That is, a is the coefficient of x square, b is the coefficient of x, and c is the constant part. Here, x can be written as minus b plus or minus root d by 2a. So d is equal to b square minus 4ac. So b square is 1 minus 4 into 1 into 1. So 1 minus 4, you are getting minus 3. So root d is root of minus 3. That is, minus 3 can be written as 3 into minus 1. So that is root 3 into root of minus 1. That is root 3 iota. So root d can be represented as root 3 iota. So x is equal to minus b plus root d by 2a, and x is equal to minus b minus root d by 2a. b is 1, b is 1, a is 1, c is 1. So minus 1, root d is root 3i by 2 into 1. So we are getting minus 1 plus root 3 iota by 2. Here you will get minus 1 minus root 3 iota by 2. So here you can see two roots. Quadratic means there will be the degree of the equation is 2, and you have to get two roots also. Two roots can be, sometime it may be equal, some it may be unequal. So that is based on the value of the discriminant, that is b square minus 4ac. If b square minus 4ac is greater than 0, real and unequal roots. If b square minus 4ac is equal to 0, you will get real and equal roots. If discriminant is less than 0, then it will go to imaginary roots. What is the one of the fundamental theorem of algebra? Ax square plus bx plus c equal to 0. A polynomial equation with complex coefficients and of degree n has n complex roots. That is the fundamental theorem of algebra. A polynomial equation with complex coefficients and of degree n has n complex roots. Similarly, Norman algebra, a polynomial equation with real coefficient has at least one root in C. Another one, you can see ax square plus bx plus c equal to 0. That is a quadratic equation, general quadratic equation. Here a, b, c all are real. Ax square plus bx plus c. If it is a quadratic equation, a should not be equal to 0. If a is equal to 0, that will become a linear equation. So condition, what is the condition? Ax square plus bx plus c equal to 0. Then a should not be equal to 0, because if a is equal to 0, that will be going to a linear equation. So if a, b, c all are real, and if we are finding out roots of the quadratic equation, if the value of d is less than 0, then it will have complex root or imaginary root that will always occur in pairs. So if the equation of the quadratic, if the solution of this quadratic equation is p plus iq, here a, b, c, the coefficient of a, b, a, x square or x and constant all are real, then if p plus iq is there as a root, as a complex root, pakka, there will be p minus iq also will be there. In a general quadratic equation, ax square plus bx plus c equal to 0. If the coefficient of x square, coefficient of x, and the constant parties completely all are real, and after that you check the value of the discriminant become less than 0, then it will go to imaginary roots. In such a case, you are getting a complex root as p plus iq. In such a case, there will be another complex root that is exactly the conjugate of the first one. If p plus iq is the root of the equation ax square plus bx plus c equal to 0, where a, b, c are real and a is not equal to 0, then p minus iq also a root of the quadratic equation. The meaning is the complex roots occur in conjugate pairs. Complex root will occur in pairs. One condition is there, a, b, c should be all real. Another one example with, we can go x square minus 2 root 3 plus 3i into x plus 6 root 3i equal to 0. So this is the quadratic equation given, but here all coefficients are not real. So if you are comparing with ax square plus bx plus c equal to 0, you can get it as a equal to 1, b equal to minus 2 root 3 plus 3i, c equal to 6 root 3i. Anyway, we can go and find out the roots of the quadratic equation by using the quadratic formula x is equal to minus b plus or minus root of b square minus 4ac by 2a. So x is equal to minus b plus or minus root of b square minus 4ac by 2a. So what we have to do? First of all, you have to calculate the discriminant, that is b square minus 4ac. Then you have to calculate root d. So b square is minus 2 root 3 plus 3i the whole square. So this is our b square minus 4ac. What is a? A is 1, c is 6, root 3i. So minus square is plus. So 2 root 3 plus 3i the whole square minus 4 into 6, 24 root 3i. So here you can apply a plus b the whole square. So 4 into 3 plus 3i square plus 2ab. Matlab means 2 root 3. 2 root 3 into 3i. So this is a square plus b square plus 2ab, like that. So 4 into 3, 12 plus 3i square. 3 square is 9, I square is minus 1. So answer will be minus 9 plus 2 into 2, 4. 4 into 3, 12. 12 root 3i. So 12 minus 9, d equal to 12 minus 9, 3 plus 12 root 3i. So d equal to 3 into 1 plus 4 into 3, 4 root 3i. So now you have to calculate root d. So root d is root of 3 into 1 plus 4 root 3i. This can be written as root 3 into 1 plus 4 root 3i. So here you are getting a complex number inside the root. So you cannot go directly and write in the quadratic formula. First you have to calculate the square root of this number. Square root of 1 plus 4 root 3i. That can be considered as a plus ib, our previous method. Now we have to square on both sides. So you will be getting 1 plus 4 root 3i equal to a square plus a square minus b square plus 2abi. See, b square is ib the whole square. So I square is minus 1. That is why minus 1 came. Now 1 equal to a square minus b square. We equated the real part. Then 4 root 3 equal to 2ab. So this is a square minus b square and 2ab. Now you know that a square plus b square is equal to root of a square minus b square the whole square plus 2 4 a square b square. Now you a square plus b square is equal to a square minus b square is actually 1. So 1 square plus 2ab is 4 root 3. So 2ab square is actually 4 a square b square. So 4 root 3 the whole square. So a square plus b square is equal to 1 plus 4 into 4, 16 into 3. 16 into 3, 48. 48 plus 1, 49. So 49 is equal to 7. So no need to take negative because a and b. In this case, a and b is assumed as real numbers. So real number, square of the real number is always a positive value. So a square plus b square is equal to 7. We got a square minus b square is already 1. Then this can be 2ab is already equal to 4 root 3. So these two equations can be added. So 2a square is equal to 7 plus 1, 8. A square is equal to 8 by 2, 4. So a can be 2 or minus 2. So So alpha is minus 5 minus 5 plus 4i. Beta is the conjugate minus 5 minus 4i. So alpha plus beta can be written as minus 10. Alpha beta is minus 5 plus 4i into minus 5 minus 4i. You have to apply a plus b into a minus b, the formula. So minus 5 the whole square minus 4i the whole square. So 25, 4i square, 16i square into minus plus 16. So 25 plus 16, that will be 41. So equation can be written as x square minus sum of root is minus 10 into x plus product of root is 41 equal to 0. So x square plus 10x plus 41 equal to 0. And his root is, and the root of this quadratic equation is alpha is equal to minus 4y plus 4i and beta equal to minus 5 minus 4i. So we know that pakka, this q of x, this is q of x, is satisfying the value of minus 5 plus 4i. The 5 minus 5 plus 4i and minus 4, 5 minus 4 are the roots of the quadratic equation x. Now we will divide. We know that if polynomial, for example, a number 12, it is divided by 3 or number can be put 13. If it is divided by 4, you can write 3 into 4, 12, 1. So this is our quotient and this is our divisor and this is our dividend and this is our remainder. Then dividend can be represented as quotient into divisor plus remainder. So similarly, any number can be, any polynomial can be represented like this. So here if I'm dividing p of x with the q of x, so I will get a quotient and I will get a remainder. Then p of x I can represent it as q into q of x plus remainder. So dividend equal to quotient into divisor plus remainder. That is applicable in the case of p of x by q of x. If we are dividing p of x with the q of x, you will get the quotient and the remainder also. Then p of x can be written as quotient into divisor plus remainder. So we will try to divide that. So x raised to 4 plus 9x cube plus 5x square minus x plus 64 is divided with our q of x is actually x square plus 10x plus 41. So if you want to get x raised to 4 here, you should multiply with x square. So x square into x square, x raised to 4 plus 10x cube plus 41 x square. When you're subtracting minus x cube minus 6x square minus x plus 64. Now you have to multiply with minus x, so minus x cube minus 10x square minus 41x. So plus 0, 4x square plus 40x plus 64. Now you can put 4. So 4 into x square plus 40x plus 4 into 41, 4 into 1, 164. So minus 0, 0, and 164 minus, so it will be getting minus 100. So here, this is our quotient, this is our divisor, this is our dividend, and this is our remainder. Remainder is minus 100. So we can write quotient dividend is equal to quotient into divisor plus remainder. So you can write P of x is our dividend, Q of x into quotient plus remainder. So Q of x, what is Q of x? X raised to 4 x square. X square plus 10x plus 41 into quotient plus remainder equal to P of x. So we know that Q of x is a polynomial whose roots are alpha and beta. So if I am putting minus 5 plus 4i in Q of x, it will become 0 because Q of x we received by using alpha and beta are the roots. We first of all we selected alpha minus 5 plus 4i as one of the root, so its complex conjugate beta minus 5 minus 4i as the complex conjugate root. By using the concept of x square minus sum of roots into x plus product of roots equal to 0, we got a quadratic equation Q of x. That means this alpha and beta, if you are putting into Q of x, that Q of x will become 0. So that same alpha is given in the question. That is given, the question given is x is equal to minus 5 plus 2 root minus 4. That is actually minus 5 plus 4i. If you are putting that value into P of x, what will be the answer? What will be the value of the polynomial P of x? So if you want to put that value into P of x, no need to put directly into P of x. You can simply put in this expression. In this equation, you can put. If we are putting the value into P of x, that meaning that we are putting that value into all these terms. So here, instead of r, you have to write minus 100. You have to write minus 100 because we got the remainder as minus 100. So if you are putting that value x is equal to minus 5 plus 4i, so that is actually the root of the quadratic equation Q of x. So this will become 0. So when you are putting x is equal to minus 5 plus 4i, this Q of x will become 0 into Q plus remainder, that is minus 100. So this entire term become 0. So finally, you are getting P of x is equal to minus 100 when x is equal to minus 5 plus 4i. So without substituting this value into the polynomial P of x, by using this idea, you are able to find the value of the polynomial P of x. So this is a simple method. Otherwise, if you are putting that value into this bigger equation, P of x equal to x raised to 4 plus 9x cube 3 for 35x square minus x plus 64, it will kill your time. So better to use this idea to solve the, or to calculate the value of the polynomial. So that is about quadratic equation. Then we told z is equal to a plus ib is the standard form of a complex number. In normal Cartesian coordinate system, we can represent a point like this, x comma y. The meaning is this much distance is x and this much distance is y. For example, 2 comma 3 means this will be 2 and this will be 3. X will be 2 and y will be 3. Similarly, we can show the complex plane. Here, x-axis will represent the real value of z and y-axis will represent the imaginary value of z. So iota you have to represent here and real value should be along x. For example, 2, 3. For example, z is equal to 2 plus 3i. So here, this is actually x plus I, y. So x is 2 and y equal to 3. So x can be taken as 2. So this point is 2. And y is 3. So this is 1, 2. This is 1 and this is 2. This is 1, 2, 3. So this point will become the corresponding coordinate of complex number. This can be represented as 2, 3. So here y will be 3i or this is 2, 3i. This is the representation of a complex number in complex plane. This is known as actually Argand diagram. Argand diagram. In this way, we can represent a complex number. For example, if a complex number is given as z is equal to 0, minus 1 and another complex number 2, 3, another complex number minus 3, 4, another complex number minus 3, minus 3. What you have to consider? This is as 0 minus I. This is 2 plus 3i. This one is minus 3 plus 4i. And this one is minus 3 minus 3i. You have to consider like this. So, here, if this general complex number z is equal to a plus I b, here in the first case, z is equal to 0 minus 1. Here a is equal to 0, b equal to minus 1. So a should be in real and b should be minus 1. So that point can be represented like this. This is x-axis, y-axis, and this point is 0, minus 1. So that lie a is equal to 0 and b is less than 0. That means that is on negative y-axis. That point on negative y-axis. Another example, z equal to 2, 3. Here, that is equal to 2 plus 3i, which is equal to a plus ib. Here, a equal to 2, that is greater than 0. B equal to 3, that is also greater than 0. If a and b both are greater than 0, means both are greater than 0. That means both are in the positive quadrant. So this will be 2 and this will be 3 and this point is 2, 3. So the point lies in the first quadrant. Another example, z equal to minus 3, 4. This can be written as minus 3 plus 4i, which is equal to a plus ib. So a equal to minus 3 and b equal to 4. A is less than 0 and b is greater than 0. That means a less than 0 means that is minus x and b greater than 0 means that is plus y. So the point lies in the second quadrant. So this can be minus 3 and this can be 4. So this will be the minus 3, 4. Another example is z is equal to minus 2 and minus 2. So this can be written as minus 2 minus 2i. Here a equal, which is equal to a plus ib. A equal to minus 2 less than 0. b equal to minus 2 less than 0. So here A and B both are negative. So that will be coming. A negative means that is coming on the negative x direction, and B negative means that is coming on the negative y direction. So this will be minus 2 and this will be minus 2. And the joining point is this one. So this is minus 2 comma 2, minus 2 comma minus 2. So the point, the complex number will be lying on the third quadrant. So in this way, you can draw Argand diagram of a complex number. This representation is known as Argand diagram of a complex number. Then another two important concepts, that is basic part of complex number only, modulus of a complex number. Another one, argument or amplitude of a complex number. So what is modulus? For example, I am going to represent a complex number 2 comma 3. So this will be 2 and this will be 3. So the point will be like this. This point can be represented as P, that is 2 comma 3. So that is 2 comma 3. So that is the point. This point is actually the origin. So modulus of Z means the length of the point, the distance of the point from the origin. So this is the distance of the point from the origin. So it is length of OP. Length of OP. Length of OP. If it is here, you can see a right triangle. If this is 3 and this is 2, this forms a right triangle. By using Pythagoras theorem, you can say that 2 square plus 3 square is equal to OP. So you will be getting 4 plus 9. Answer is root 30. So this is root 30. So this can be represented as R. R is equal to modulus of Z. R is equal to modulus of Z. That is, if Z is equal to A plus IB, and this is A and this is B, this point is A comma B, and you are getting a triangle like this, and this is 90 degree, this is B and this is A. So this length will be root of A square plus B square. So modulus of Z is equal to R equal to, you can like this, A square plus B square. So what do you have to do? If you want to calculate the modulus of a complex number, take the square of the imaginary part and real part and add it together. Then calculate the square root of the result. Another example. Z is equal to 4 plus 3i equal to A plus IB. So modulus of Z can be represented as root of A square plus B square, which is equal to root of 4 square plus 3 square, that is equal to 16 plus 9, which is equal to 25, that is equal to 5. So that 4 and 3 will be like this. This will be 4 and this will be 3. So the point will be like this. This is 4 comma 3, and you are getting a right triangle here. If this is the point P and this can be represented as OP, and this is R, R is equal to modulus of Z. So by using Pythagoras theorem, that is root of 4 square plus 3 square, you are getting root of 25, that is 5. So R equal to, you are getting 5. That is modulus. So this much of basics are there in complex number. Then now we need to discuss about the amplitude or um, amplitude of the complex number regarding the angle part, that is theta. So next class we will discuss about the uh, remaining part of the complex number. Okay, please watch this video, and if you have any queries, please contact. Thank you for watching. Thank you all.